So today we're going to talk about Hardy-Weinberg equilibrium and how a selection may affect these equilibriums. So we're going to use a fictional species called mini bears with color alleles big B and little b, and these three are the genotypes big B, little b, and little b, with the three phenotypes that accompany them with red, gold, and green. And over here are the population statistics. So we have 25 individuals with big B, 50 individuals with big B, and 25 individuals with little b, leading to a total of 100 bears. So to prove it's in Hardy-Weinberg equilibrium, we want to first calculate the initial allele frequencies. So the frequency of the big B allele is going to be the total number of big B alleles divided by the total number of alleles. So this is going to be 200 because although we only have 100 individuals, each individual has 2 alleles in these diploid organisms. So it's going to be 2 times 25 plus 50 divided by 200 equals 0.5, which will be your p value. And the second one will be the same exact calculation, which will give you your q value. And the Hardy-Weinberg equilibrium equation says that p plus q equals 1. So we can do these calculations knowing that we are in Hardy-Weinberg equilibrium. Now that we have the initial allele frequencies, we're going to calculate the initial genotype frequencies. So to do this, what you need to do is have your number of desired genotype individuals divided by the total number of individuals to get that frequency. So for big B, it would be 25 individuals divided by 100, which is the total, to give you 0.25. And then you do that for the rest of the genotypes, getting 0.5 and 0.25 red, gold, green. And we can also see this with the Hardy-Weinberg equation. That's p squared bb plus 2pq big B plus q squared little b, which would be 0.5 squared plus 2 times 0.5 times 0.5 plus 0.5 squared again, which will give you the same frequencies that we saw with this. Now we are going to introduce selection into our population. Imagine that the habitat for this population of mini bears is very forested with a lot of grasses and shrubs. This allows for sufficient shelter so that color does not affect fitness. Suddenly, a corporation decides to cut the forest down. The new habitat that lacked intense greenery led to prey of mini bears being able to hunt them more easily. With that said, the golden bears can more easily blend in with the new brown landscape, causing the green and red bears to be selected again and more easily hunted. Now we have a chart that will allow us to get our frequency after selection. So we start with our initial frequencies from last time, and we have the fitness with the gold bear having the highest fitness since it is the least selected against. And then to calculate the unadjusted survivors, what you have to do is multiply the initial frequency by the fitness, and you receive these values. And then to get the frequency after the selection, you have to do the unadjusted survivor divided by the average fitness, which is calculated by adding each of the unadjusted survivors together, leading to the frequency after selection. And as you can see, big B lowered, big B increased, and little b decreased, leading to stabilizing selection, which favors the heterozygous genotype. If we were to see this selection continue, we would see an increase in the heterozygote gold bears and a decrease in the homozygotes, which would be the red and the green bears, leading to stabilizing selection.